we are going to discuss the interaction of radiation with matter by use of electromagnetic radiation. First of all, we see the schematic representation of this electromagnetic radiation absorbed by the atoms or ions or the molecules. Spectroscopy is the use of interaction of radiation with matter uses absorption, transmission, reflection, and so on. When the atom or the molecule absorbs this electromagnetic radiation, what happens here? When the atoms or molecules absorb the electromagnetic radiations, at that time some of the radiations gets absorbed, some of the radiations get scattered, some of the radiation gets transmitted, and some of the radiation gets scattered along with in any one direction. Okay. First of all, we will see one by one these criteria. When the electromagnetic radiations are incident on the atoms or ions or the molecules, at that time energy is absorbed by the molecules. What kind of energy is absorbed by the molecules? Molecules which gives rise to the amount of wavelength absorbed by the molecule. And this absorption raise the molecule into its lower energy state to a higher energy state. Okay. When the electromagnetic radiations are absorbed by the other kinds of atoms or molecules, at that time some of the radiations get scattered without reflection. Get scattered like this, and thus there is no reflection. Okay. When electromagnetic radiations are absorbed by the atoms or ions, at that time some of the radiations gets transmitted. Like that way, here interaction of electromagnetic radiation with the atoms or molecules results into these types of phenomena. Now first of all, we see what is meant by the here. Now we will see the meaning of the absorption. For example, suppose this is an atom. When this atom absorbs electromagnetic radiation, this atom absorbs electromagnetic radiation, at that time what happens? The incoming energy excites the quantity is the structure. Quantity is the structure to get into a higher energy level. This excitation brings with the help of the wavelength absorbed by these atoms. Therefore, the type of interaction which are taking place in these atoms depends upon which type of wavelength is absorbed. Now these wavelengths are absorbed by means of following criteria. See here, which are the criteria? When UV radiations wavelength are absorbed, electrons are push up the atoms into a higher energy level. Okay, that is what I am to say. That is, when UV radiations are absorbed by the atoms, at that time electrons push the atoms to transfer into a lower energy level to higher energy level. When IR radiations are absorbed, at that time vibrational excitation takes place. And when microwave radiations are absorbed, by this atom, at that time rotational excitations takes place. Now, what to be concluded? That is, when the atom absorbs electromagnetic radiations of which wavelength of first is of when UV radiations are absorbed, electrons push the atoms into a lower energy level to higher energy level. When higher radiations are absorbed, at that time vibration and excitation takes place, and when microwave radiations are absorbed, rotational excitation takes place. But after absorbing the radiations, we get the interaction in the atom. This interaction in the atoms or molecules tends to know its type of bonds, its internal structure, and identification of the compound. Identification of the compound. Okay, but the spectrum is of, suppose this is an absorption spectrum. This absorption spectrum is a function of energy with the wavelength. Energy with the wavelength. Okay, in other words, in the last lecture we have seen that when the energy is increased, at that time the wavelength is decreases. According to which equation? See here. We have the equation. Suppose this is the atom A is of ground state. When it absorbs electromagnetic radiations, it transfers into a higher energy level. It is called as a excited state. Okay, excited state. From ground state to excited state, what amount of energy is absorbed is given by the relation, that is E is equal to E2 minus E1. Here energy absorbed, that is equal to E2. Here Auger energy is equal to E1. Therefore E2 minus E1, that is equal to delta E. And we have delta E is equal to H into nu. Okay, where H is equal to Planck's constant, and which have the value 6.67 into 10 raised to 31 joule second, and nu is equal to frequency, and we have the relation nu is equal to C upon lambda. As H is equal to Planck's constant, it is a Planck's constant, it is a constant value. Therefore, change in energy or delta E is equal to constant into C upon lambda, where C is also called as velocity of light, and it has the values 3 into 10 raised to 8 meter per second. Therefore, this value is also constant. Therefore, we have the relation, that is delta E is equal to what remains? Constant into constant. Okay, constant into constant divided by lambda. In other words, we can say that is delta E is equal to constant into 1 upon lambda. That is delta E is inversely proportional to 1 upon lambda. And this is the final relation, that is when the electromagnetic radiations are absorbed by the atoms or molecules, at that time whatever may be the energy, if at that time wavelength is decreases. That is energy and wavelength are inversely proportional to each other. That is delta is inversely proportional to 1 upon lambda, where lambda is the wavelength of light absorbed by the atoms. Okay. Now the next criteria is the emission. Once the atom, suppose this is an atom in a ground state, after absorbing electromagnetic radiation, it transferred to a higher energy state, that is the excited state. Excited state. See here. Now, when the atom undergoes in an excited state by absorbing electromagnetic radiations, okay, it has the higher energy. It has higher energy, but it tends to return its original ground state by emission of certain energy in the form of light or the some kind of rays. It is called, this process is called as emission. But in case of atoms, case of atoms, when atoms are excited by high energy temperature, at that time this emission is also known as atomic emission. Atomic emission. When the molecules are excited, it is called as when the molecules are excited, it is called as only emission or molecular emission. Okay, and when the emission takes place by losing excess amount of energy without change in spin state of electrons, it is called as phosphorescence. It is called as phosphorescence. Okay. Now we will see the another criteria that is known as a fluorescence. Here I can draw some diagram. What is meant by fluorescence? Suppose the energy level diagram. This is S0 and this is a S1. Suppose these are the electrons. This is the ground state. S0 is called as ground state. S1 is called as excited state. Okay. Now suppose that here the transitions from ground state to excited state to ground state are here shown. But now what is meant by the fluorescence? When the atom absorbs electromagnetic radiations, it undergoes the higher energy level, and in a higher energy level, when the lifespan of higher energy level of an atom is very low, at that time it loses its extra energy in the form of re-emitted light, and it returns to its original position, that is, it returns to a ground state. That phenomenon is known as a fluorescence. Okay, that is when, suppose when this is an atom, it is a ground state. When it absorbs electromagnetic radiations, the incoming energy gets quantized. They will pull the electrons to push up in a higher energy level. Suppose this is a higher energy level, but in this higher energy level, whatever may be the excited state of electrons, have the lifespan is equal to very short, and therefore they coming to their original ground state by re-emitting the energy, excess of energy, in the form of light or photons. This phenomenon is known as the fluorescence. Okay. Now last phenomenon is about the scattering. What is meant by the scattering? Okay. Scattering. When the atoms absorbs electromagnetic radiations, absorbs electromagnetic radiations, and again they scattered, and they scattered in the same direction, as that of incident light, the phenomenon of scattering of light is known as Rayleigh scattering. Is known as Rayleigh scattering. Thus, the interaction of radiation with matter uses four phenomena. First is absorption, second is emission, third is scattering, and fourth is reflection. Whatever may be the atom absorbs electromagnetic radiation, some of the energy it gets emitted in the form of a light. But when we have to study the organic molecules in terms of, by using the spectroscopy, organic molecules when absorbs electromagnetic radiations, they interact with radiations. At that time, whatever may be the energy which is raised by the absorbing electromagnetic radiations, push the electrons in a higher excitation state. This excitation depends upon the type of wavelength is absorbed by the atoms or molecules. Now, which type of wavelength is absorbed is seen by the type of excitation. Now, this type of excitation, after type of excitation, when electrons are excited by the atoms, when electrons are excited, at that time we come to conclusion that is UV radiations are absorbed. In other words, when UV radiations are absorbed by the atoms, electrons gets excited. When IR radiations are absorbed by the atoms, at that time vibrations are gets excited. And when the microwave radiations are absorbed by the atoms, at that time rotational excitation will takes place. Rotational excitation will takes place. In other words, we can say in short that UV radiation, electrons are excited. IR radiations, vibrations are excited, and microwave radiations rotations are excited within the atom or molecule. Now, these type of excitations takes place in atoms or molecules in terms of absorption of energy. Now, in terms of absorption of energy, which can be measured in terms of rotational energy, vibrational energy, and electronic energy, when the radiations are such as either microwave, IR, and UV radiation. In short, we have to write the energy level diagram. Diagrams for molecules. When the molecule can absorb UV radiation, at that time which vibrations are observed? In UV radiations, electrons are excited. In IR radiations, vibrations are excited, and in microwave, rotations are excited. In between these three, UV radiations are stronger one. That is, when microwave radiations are absorbed by the atoms or molecules, at that time rotational energy levels are only observed. When IR radiations are absorbed, at that time vibrations are excited. At that time, two types of levels, that is rotational level and vibrational levels, are subjected. And when UV radiations are absorbed, at that time three excitations, that is rotational, vibrational, and electronic energy levels are subjected in a UV radiations. Now we will see in the next lecture, that is energy level diagram for the molecules which undergoing either UV, IR, or microwave radiations. Thank you.